Hi everyone, this is Smriti. Welcome to my channel QA Automation Classes. Hope you are doing good. So today I'm going to start a new series that is called as the functional programming in Java. Okay, so we'll cover like lambdas and functional interface and types of functional interface like user defined functional interface as well as the pre-defined functional interfaces. Okay, with different examples. So let's start, guys. Okay, so first thing is why functional programming, right? So you guys know, right, up to Java 1.7, right? So if you want to write a single line of code or single piece of code, okay, you cannot write it independently, right? So if you suppose, I'll give one example. Suppose you want to say I will just write one line of code where I just want to print SOP, okay, system.out.println. Suppose I want to print hello world. Okay, so this is the thing what I want to display. Okay, so now I'm going to display hello world. So I cannot write a single line in the Java to accomplish this one, right? So for that one, what we can have up to Java 1.7. So for this, what we can have a class. Okay, so we can have a class. Suppose I'm saying class A. So inside the class A, I'll write so let's see, public. Okay, so let's see, void that doesn't return anything. I'll just print. Okay, so I'll say method m1. Okay, any method name you can give, and here you will write SOP. Okay, and here you can write your actual method implementation, what your method is supposed to do. So I'm saying my method is supposed to display hello world. Okay, and then okay, and then public static void main. Okay, and here string array of arguments. Okay, and then here I'll say I'll create the object of class A equals to new A, right? And then I'll say a dot m1. Okay, so now the entire code, right, this entire code is going to print one line of output, that is hello world to me. So this is called as the object oriented approach, right? So everything in Java is was represented up to 1.7 in the form of the class and objects. So a class and the respective object. Okay, this is object, this is object reference, and with that we call the different methods or the variables, right? So this is how we used to get our job done up to Java 1.7. But there are so many different functional programming languages, right, that doesn't need all those things, right? So in Java 1.8 onwards, the Java people also started implementing those functional concept into the Java. So let's see how exactly what is the functional programming, right? So how we can achieve this functional programming in Java 1.8. Okay, so the function, why exactly the functional programming I explained, right? In order to write one single line of the code, we need to go through a specific process. We need to define a class, we have to define the method, we have to create the object, and we have to call the method, right? So but now suppose we want to write just one single line of code where I'm going to print hello world. Okay, so an independent piece of code, right, that cannot exist in the Java up to Java 1.7. So in Java 1.8, with the help of the functional programming, we don't have to essentially go through the whole process like creating the class, creating the object, creating the method, and calling them. We can have a single piece of code, right, and independent piece of the code. Okay, so that is the main intention why functional programming is implemented in Java 1.8. Okay, so how it is going to be implemented? So it can be implemented with the help of the lambdas. Okay, so what exactly a lambda is, right? So lambda is kind of like, you can say, it can exist independently and can be assigned to a variable, and we can refer the block of code with a variable name. Okay, so what is that, we'll come to that in like a little bit of time. So let's see what are the lambdas, right? What is the characteristics of the lambda? So lambda, okay, the name lambda, right? MBDA, the lambda, okay. So this is T. So lambda, it enables the functional programming, okay. So with the help of the lambda we can enable the functional programming features, okay. And then, so because of these lambdas we can have readable code, okay. Readable code, concise code, okay. The code will be very concise and it will be readability will be more, and we will be get rid of the boilerplate codes, right? And then there are few the API which implements this one is really easy, okay. So easy to use API, easy to use API. So these are the concepts, right, behind the lambda. These are the pointers, okay. So now let's see how can we convert a normal method to the lambda, okay. So suppose so till now what we knew, so we came to know like with the help of the lambdas we can enable the functional programming, right? So let's see, suppose there is a normal method and I want to convert it into the lambda. So how can we convert, okay? So let's see, public, so I'll say public, okay, and the method will have a return type. I'll say void, okay, public void, and then I'll say, suppose I'm just going to print some names, okay, print name, okay. So this is nothing but a method, okay. So I'll say system.out.println, okay. I'll say QA automation, okay, classes by Smriti, okay. So this is what is my print statement, okay. So this is my print statement, okay, and then the closing braces for the method. So I declared a method, and inside the method I just have a single SOP statement, system.out.println QA automation classes by Smriti, okay. So now let's see, this is a method which we can design up to Java 1.7. even in 1.8 we can design normal methods, but yeah, our intention here is to convert this method to a lambda, right? So how to convert a normal method to a lambda? So lambda equivalent, first of all, there are few steps we need to follow. So first step, get rid of the access specifier, okay. So what is the access specifier here? So this is the one, right? Public is the access specifier, right guys? This is the access specifier. So get rid of the access specifier. So let's see step 1, okay, access specifier, access specifier. So we need to get rid of access specifier cross, okay. So after getting rid of the access specifier, what I will be left with? I'll be left with void, okay, print name, void print name, okay, and here I'll have SOP statement, right? SOP QA automation classes by Smriti, QA automation classes by Smriti. So this is what I'm going to have, okay. So I got rid of the access specifier. The step 2 is get rid of the return type, okay. So now I'll say step 2, get rid of return type. So now delete the return type. So return type here is void. So from here, so what we are left with? We are left with the print name and the SOP statement, okay, sorry, print name and the SOP statement. So consider the SOP statement is there, right? Okay, so this is what we are left with. This is the step 2. So now going to the step 3, okay. The step 3 is also get rid of the function name, right? So we don't want the function name also now. So step 3, so function name, okay, function name. So we'll get rid of function name also. So here you see the function name is print name, right? Print name is a function name. After that we have the parenthesis, right? So since we are getting rid of the function name, so what we are left with? We are left with the parenthesis, right? So we are now left with the parenthesis. Let me take this color. And parenthesis, inside the parenthesis we have the braces, curly braces, and there we have the SOP statement, right? Something is there like welcome to QA automation classes by smoothing, right? And now step 4. Okay, so we got rid of the class name here, so it becomes the anonymous function, right? So now step 4. Step 4 is introduce the lambda sign. Step 4. Okay, introduce lambda sign. Introduce lambda sign. Lambda sign. How to introduce lambda sign? Let me take another pencil. Orange one. Okay, fine. So lambda sign is nothing but the your function. So this is the lambda sign, arrow symbol. Okay, this arrow symbol is called as the lambda sign. So now what is left here? If you see SOP, and here I still have the welcome to QA automation classes by smoothing, right? And now the next one. Okay. So now we got rid of the access specifier, we got rid of the return type, we got rid of the function name. This is got rid in, this is got rid in, and this is got rid in. So we are left with only this one, and then we have introduced the lambda symbol, hyphen, and the greater than sign, right? And then we have within the curly braces we have the SOP statement till now. Okay, this is the step 4. So now step 5. Okay, step 5. So what we are going to do in the step 5? Step 5 is saying, so assign it to a variable so that we can refer or call it, right? So here why we need a variable for the assignment? Since you don't have any name here, right? Suppose you want to do some operation, this method is doing some operation, right? So this function is doing some operation, but how you are going to call it? You have to call something by its name. Since we don't have any name here, we got rid of the function name, right, in the step 3. So how you are going to refer it, how you are going to call it? So you have to assign it to a variable name. Okay, so now I can say step 5, assign to variable. Okay, so this variable is something we need to discuss in the detail going forward. Okay, so I'll tell you that is nothing but the functional interface. Okay, so now I'll say var1, suppose whatever name I'm giving, equals to the function symbol and the lambda sign and then SOP. Okay, and here welcome to QA automation classes by smoothing. And now the last step. Okay, so last step, step 6. Okay, so since we have only one line here, right, just one SOP line, then these curly braces are also optional. Okay, so since we have only one line of code, the curly braces are also optional. So I can say, let me say the final one. So I'll say var1 equals to this one, type symbol SOP, and here give welcome to QA automation classes. Okay, this is what we are left with. Let me write it clearly so you guys are clear, right? So let me delete this one. So let me quickly walk you through one more time what we did and with what we are left with. Okay, so our main method was, the actual method was, so public, let me take this one. So the method was public, okay, void, okay, so then equals print name, okay, void print name. Okay, so here I just had one single statement SOP, and I just saying something welcome to QA automation classes by smoothing. So this was the statement, or this was the method. Okay, so now there are the 6 steps. Through 6 steps we came up with the lambda equivalent for this one. So the first step was we have to get rid of the access specifier. So access specifier is public private protector, so get rid of this one. And the second one is get rid of the return type, so we got rid of the void. Okay, and then the third step is get rid of the function name. So function name is print name, so we got rid of that one as well. And the fourth one, okay, so fourth one is so you have to introduce something. What is that? That is the lambda symbol, hyphen and greater than symbol. So this is the introduction of the lambda sign. Okay, and then step 5, we need to assign it to a variable. Since we are getting rid of all these things, even function name we are getting rid of it, we need to call it with a some name, right? So I'll say variable 1 equals to, okay, then function symbol lambda, and then here you say SOP, system.out.println, whatever you say here. Okay, so now we are left with this code. And now the last step, the step 6 says, since we have only one line of code, right, this is only one line of code inside the method, so we can get rid of this curly braces also. So now I am left with what? So this is the final lambda equivalent, I can say. So I'll say I am left with var1 equals to, okay, function symbol lambda symbol, and I'll say SOP, system.out.println, and whatever, welcome to QAAUTOMATION classes by Smoothie. Okay, this is what we are left with. So if you see, for this method the functional equivalence, right, or the lambda equivalent is this line. Okay, right? So I think everyone is clear up to this point. Okay, so if you guys have any doubt, please feel free to put them in the comments. I'll get back to you as soon as possible. Okay, so as I already told you, so we need to define the type of variable which is the functional interface type. Say I am saying this variable 1, right? So what exactly is the variable 1? That is nothing but the functional interface type. Okay, so we can now pass the lambda expression or the variable to a method. Okay, so this lambda expression can be passed to a method, or we can even pass the entire lambda expression to a method. Okay, so and there is one more concept is called as the functional type inference. Okay, so I'll talk about that one when we come to the actual examples. Okay, so now let's have few more examples where we are going to convert them into the different lambdas. Okay, so this is like a simple method which didn't have any argument and it was not returning anything. So let's have few combinations of them and see what will be the corresponding lambda equivalent. Okay, so now let's say I have a method called public, okay, void, so sum. Okay, so in the sum I have the int a comma int b. So it takes two argument, int a comma int b. Okay, and then is going to print out SOP a plus b. Okay, so this example, like, it takes two argument but doesn't return anything. Okay, right? So now let's try to convert it into the equivalent lambda. Okay, so now what we need to do? Okay, so first get rid of the access specifier, get rid of return type, get rid of function name, and then introduce a lambda symbol. Okay, so after getting rid of these three things, access specifier, return type, and function name, we have, let me take a different pen. So what we are left with? We are left with int a comma int b. So we are left with int a comma int b, and if you see, we have to introduce the lambda signs. This is step number 4, lambda sign we introduced, and here we have SOP, okay, a plus b, right? Okay, and now since this is a single line of the code, right, since this is a single line of the code here, so we can get rid of the curly braces as well. So now we have the equivalent lambda is int a comma int b, okay, and lambda sign and just say SOP, okay, a plus b. So this is what is the equivalent lambda expression of this function. So this is the function and this is the lambda equivalent, okay. So this is the second example, okay. So now let's take another example which takes some argument, okay, and which returns some value also, right? So let's see. So let's say we have an example where we are calculating the area of the circle, okay. So I'll say public, so I'll say public, I'll say int, okay, and what I'm trying to do here, I'm calculating the area of circle, area of circle, okay, area of circle. In this area of circle I am taking argument that is int r, that is radius, okay. I'm taking the radius and then I'm going to, on top of this I'm going to return something, right? I need to calculate the actual value area of the circle. So I'm going to say return, okay, so 3.141 into, okay, r into r. So this is what I'm going to return, okay. So this is my function, okay, this is my function. So now I am going to convert it into the equivalent lambda, okay. So now what we know, we need to get rid of first the access specifier and then data type, sorry, return type, and then method name, okay, and we'll be left with the parenthesis and the whatever the input we want to give. So we'll be left with enter, then we need to introduce a lambda symbol, okay. And since we are returning something, then since single line we can get rid of that, we'll see how it is, right? Okay, so the corresponding lambda will be I'll say, so int, okay, I'll say int r, okay, this is the input, and then, okay, so here I'll say, okay, here I'll say return, right, return 3.141 into r, okay, into r, okay, right. So here if you see, since there is a single argument here, right, so no need of the parenthesis, we can get rid of that parenthesis as well. So I'll say int r, okay, so 1 2, so I can say return, since this is single line, okay, I'll say return 3.14 into r into r into r, okay. So now, okay, I talked about the type inference, right? So what is a type inference actually? The type inference is at the runtime Java can determine what type of data is being passed, okay. So if we are going to give the integer type of data or float type of data or double, whatever, right, so it can identify those. So for that reason you don't need to mention the data type also int here. So now we are left with what? We are left with, let me take another column, so r, okay, I'll say return okay, since this is only one line, okay, so one line also, right, we can get rid of this return statement also. So I can directly say 3.141 into r into r into r. What does it mean? It means whatever input type you are giving, suppose that is you are giving 2, so that r value is 2 now, so 2 translates to 3.141 into 2 into 2 into 2. Sorry, this is pi r square, right? I have been doing cube, right? Okay, up to this. Okay, sorry about that. So let me take this one into r into r. Okay, so into r into r. Okay, this is fine now. So this is what we are left with. The final one is r, I can say lambda equivalent 3.141 into r into r. Okay, so this is nothing but the functional type functional like type inference, right, we can say, and this is the lambda equivalent. Okay, so I hope it is clear for all of you, like how to create the functional functional interfaces that I am going to cover in the next session. So till now we covered like what is the normal method, okay, how to convert that normal method into the different functions, right? So or the different lambdas. Okay, so that's all for this session. Okay guys, so in the next session we're going to start with a sample example, right, how it is going to be implemented with the help of the interface. Okay, so with the help of interface or functional interface. Okay, and then we'll go further and we'll try to explore different types of the functional interfaces, right? So first we'll see the user defined functional interfaces, and then we're going to have the predefined functional interfaces. Okay, so that's all guys. Thank you for watching the videos. Please do subscribe to my channel and press the bell icon to get notified about new videos. So this is Smriti signing off for today with a promise to learn something new tomorrow. Have a good day. Bye bye. Thank you.